Welcome, everyone. I previously discussed how CO2 has maintained today's hospitable climate in the video titled How CO2 Saves the Earth, Greenhouse Gases, Vital Warming, and Cooling Effects. But as our lower atmosphere saturates with CO2, additional CO2 has much less of an effect today. The big five natural climate dynamics, when considered together, offer a far better explanation of both regional climate trends and the statistical global warming trend since the end of the Little Ice Age. The first of the big five identifies the effect of varying transport of warm Atlantic waters into the Arctic. Jonathan Call's analysis of Arctic surveys between 1950 and 1990 and published in the preeminent journal Nature, found no rise in Arctic air temperatures. But after the 1990 shift of the Arctic oscillation, which caused sub-freezing winds from Siberia to blow insulating Arctic ice out of the Arctic, Arctic air temperatures suddenly began warming several times faster than the global average temperature. The loss of insulating sea ice increased the ventilation of stored ocean heat, warming the air but cooling the ocean. That warming offset and obscured the 25-year winter cooling trend in both North America and Eurasia, represented here by the blue colors. Clearly, Arctic warming is due to regional climate dynamics, not global. From Danish sea ice records and modern satellite photos, we see two distinct periods with very similar reductions in the extent of Arctic sea ice, one during the 1930s and one since 2000. Those two periods of reduced sea ice are separated by an intervening 30-year period of increasing sea ice, suggesting sea ice is modulated more by a natural oscillation. The Atlantic multi-decadal oscillation represents a natural cyclical dynamic where the northern Atlantic waters alternate between becoming warmer than the southern Atlantic and then becoming cooler. It cycles approximately every 60 years. The decades when water temperatures were 0.3 to 0.5 degrees Celsius warmer in the North Atlantic waters, it coincided with the decades of reduced Arctic sea ice and rising global temperatures. The decades between 1950s and 1990s, when North Atlantic temperatures were 0.3 to 0.5 degrees Celsius cooler, the Arctic sea ice increased and there was no global warming trend. As climate scientist Moreno Chamorro published in 2020, these alternating periods of warmer and cooler North Atlantic temperatures have also correlated with the changes in the Intertropical Convergence Zone, or ITCZ. The ITCZ is a migrating band of rising air that sailors call the doldrums, which also brings heavy rainfall. Over Asia and Africa, it follows the sun to the tropics of Cancer or the Tropic of Capricorn, according to each hemisphere's summer solstice. The ITCZ is also the driver of the Earth's Hadley circulation that constantly transports warmth and moisture from the tropics towards the poles. Where the north and south trade winds converge defines the ITCZ's position and determines where the rising branch of the moist air of the Hadley circulation will create a rainy season. Because the ITCZ determines the location of tropical rainy seasons, it leaves strong clues to how its location has changed over centuries and millennia. Around 30 degrees north or south of the equator, the air moving towards the poles at the top of the atmosphere converges with the atmospheric winds that are moving back towards the equator. This upper air convergence drives air currents downward to create a quasi-permanent high-pressure region at the surface. Also 60 degrees north and south, the convergence of opposing surface air currents drives air upwards, producing a quasi-permanent low-pressure region. As the ITCZ migrates north and south, so do these interconnected high and low pressure systems. As illustrated by Zhou's 2014 research paper, during the Little Ice Age, when the ITZ migrated southward, so did its associated pressure systems. Its more southerly location caused warm equatorial currents to be deflected southward by the point of Brazil. The southward migration of the associated North Atlantic pressure systems also steered warm Gulf Stream waters more eastward, reducing warm water flows into the Arctic, resulting in cooler temperatures that enabled the greatest Arctic sea ice buildup in 6,000 years. When solar irradiance increased, marking the end of the Little Ice Age, the ITCZ and the associated pressure systems all migrated northward. Now, the more northerly location of the ITCZ guided more warm tropical waters north of the point of Brazil, causing more warm water to flow across the equator and feed more warm water into the Gulf Stream. Additionally, the northward shifting North Atlantic pressure systems increasingly drove more warm Gulf Stream waters into the Arctic, which reduced Arctic sea ice. Now, changes in solar irradiance and sunspot cycles correlate with that migration of the ITCZ. 3 sunspot minimums and reduced solar irradiance occurred during the Little Ice Age and correlates with the ITCZ's southward migration, illustrated here in blue. The increasing solar irradiance since the end of the Little Ice Age correlates with the northward migrating ITCZ and our current warming trend. As the northward migration of the ITCZ resulted in the more warm water entering the Arctic, that warm inflowing Atlantic water circulates around the Arctic for 25 to 30 years at 100 to 900 meter depths. That warm Atlantic water keeps most of the Barents Sea inside the Arctic Circle free of ice all winter. And warm Atlantic water circulating along the shallow Eurasian coast, combined with winds from Siberia to push sea ice away from the coast and maintain ice-free pollinia during the winter, with open waters that further expand during the summer. The insulating effects of sea ice determines how quickly the Arctic Ocean will cool and how much heat ventilates and warms the Arctic air. According to peer-reviewed studies by Ignatius Rigger, published in 2002, 3-meter thick ice can ventilate 5 times more heat, about 10 watts per meter squared, than is radiated by added CO2. Where older thick ice is replaced by thinner 1-meter thick ice, about 15 times more heat than from CO2, about 30 watts per meter squared, can ventilate. And newly forming thin ice can ventilate 350 times more heat than our added CO2, about 700 watts per meter squared. It is this ventilating Arctic heat that has amplified Arctic and global air temperatures. Is illustrated here by NASA's National Snow and Ice Data Center. In summer 1985, over 1/3 of the Arctic Ocean was covered by old 3+ meter thick ice, represented here in white. That abundant, thick, insulating ice explains why Jonathan Call's 1993 analyses found no Arctic warming. After cold, freezing winds began removing that thick ice in 1990, by 2017, less than 5% of the Arctic Ocean was covered by old 3+ meter thick ice. The amount of open water, in dark blue, more than tripled during the summer, allowing much more stored ocean heat to ventilate. To blame CO2 for the sudden loss of Arctic sea ice, clearly caused by the 1990s strong shift in wind direction during a positive phase of the North Atlantic oscillation, 6 leading advocates of the CO2 warming theory, including NASA's now chief climate modeler, Gavin Schmidt, published in 2002 that rising CO2 controls the natural North Atlantic oscillation. And I quote, 4 of the 5 general circulation models show an unambiguously positive Arctic oscillation, and North Atlantic oscillation response to the greenhouse gas forcing, consistent with the hypothesis, which is their hypothesis, that the observed upward trend in these indices is anthropogenically induced. But this illustrates how badly Gavin Schmidt's conclusions have been biased by his advocacy, such as his efforts on the so-called Real Climate website that he co-founded with Michael Mann, where he advocated for a hypothetical CO2-driven climate crisis. In the real world, despite continued rising CO2 concentrations, and despite Schmidt's unambiguous modeling results, the North Atlantic oscillation has been doing the exact opposite. It has been trending more negatively for the past 2 decades. Oddly, despite this utter modeling failure, Gavin Schmidt was awarded the position of NASA's GISS director, replacing the prominent climate alarmist James Hansen. So changes in natural climate dynamics firmly dispute alarmist claims of a rapidly approaching CO2-driven climate crisis. First, increasing Arctic temperatures are chiefly caused by ventilating stored heat that warms the air but cools the ocean. The lowest solar irradiance in 100 years, the sunspot cycle 24, suggests further cooling of the North Atlantic. Third, declining solar irradiance suggests a southward migrating ITCZ, causing less northward transport of tropical heat. The coinciding shift of the Atlantic multi-decadal oscillation further suggests cooler North Atlantic waters entering the Arctic in coming decades, and would predict that as older Atlantic waters circulating in the Arctic for 30 years finally cools, conditions would allow the Arctic sea ice to recover. And finally, because most climate models and leading climate scientists incorrectly attributed rising CO2 to the North Atlantic oscillation shift to its positive phase, their alarmist crisis claims should be viewed with a great amount of skepticism. So I urge you to consider the effects of natural climate dynamics, as this is just the first of the Big Five that better explains our current warming trends. So up next, number 2 of the Big Five climate dynamics, how shifting jet streams affect global temperatures. And until then, embrace renowned scientist Thomas Huxley's advice that skepticism is the highest of duties and blind faith the one unpardonable sin. And if you appreciate the science clearly presented here, science rarely presented by mainstream media, then please give it a like, give it a share, or copy the URL of the video and send it to friends. Subscribe to my channel to see upcoming videos and past videos. Or read my book, Landscapes and Cycles, An Environmentalist Journey to Climate Skepticism. Thank you.